Right? First hand, waiting. There we are, in the middle. Just wait for the mic. Please identify yourself and then ask your question.
Philip Davies from Surrey Satellites in the UK. Question really to any of the panelists. I was quite struck by Laurie's presentation about building an architecture rather than being a mission. So working with lots of partners. So how important do you consider interoperability between all of the space assets, and is there any detail you can give about the work that's being done to ensure interoperability in terms of standards for communications, navigation, and so on?
Okay. Laurie?
This is on?
Yeah.
Okay. James may have more information than I do even. So again, keep in mind, I'm just walking in the door. But from what my understanding is, and what I'm learning and trying to understand in more depth, is what the architecture does is provide the framework and identify what the key pieces that are needed in order to achieve the end goal. So you can identify where the places are that any partners, whether they be commercial or international, can plug in and provide the needed piece parts that build towards the success of the overall architecture. So once those pieces are identified, then there is a big process, a formal process for establishing what the interface controls are going to be between those elements to make sure that there is, making sure everything matches up together. I think there is a lot of discussion right now. Even I'm already hearing just a couple of weeks on the job of things like the two human landing systems and making sure that we have the ability to have standard ways to communicate back and forth with various pieces of the architecture and things like that. So I know there's a lot of conversations there. So you've now reached the depth of my knowledge right there. James, you want to add?
I can say something. So maybe some of my ESA colleagues here might know more about the details of the specific different kind of interfaces and standards that we're talking about. But clearly, an international public-private architecture requires that there are standards for interfaces. And if you look at perhaps the different commercial lunar lander missions or commercial communications relays that are planned with the communication systems that are on Gateway or on the Moonlight, on the surface elements, there are lots of different interfaces, lots of different standards being used. And we clearly need to move into a more common way of doing that. There are discussions going on internationally, both at quite high level and at detailed technical level, on those different standards and interfaces. It's a flag that comes up all the time. I don't think there's a single way that we find our way to the standards, but there is a lot of work going on to try and identify what they should be. And in the particular ones that might be of interest, we can perhaps talk in more detail about what's happening in those areas.
I can give you a bit different angle. I'm always an outlier within my institute. Even though I'm a deputy director general, I'm from planetary science, and I'm always treated like an alien within my institute because my institute is really engineer-oriented, dominated. And talking to especially senior people, they are really proud of doing everything all by themselves, from the launcher all the way to the lander. But that's not what's happening today, right? We share the roles. And setting the standards correctly is the key to making that role sharing. Some people provide a transportation service all the way to the surface, and then you have your rover working on the surface. So this, more efficient way of, involving more people and working in a more, you can focus on what you're really good at and do something else, ask somebody else to do the other parts to enable a mission. I think that's happening, and that's why setting the standards correctly is the key.
Yeah, would either of you online, Anil or Hessa, would like to add anything in your context? Anil?
I think, yes, may I?
Go ahead.
Okay, yeah, so I think it's going to be an international participation, which will be certainly very useful. And in that case, it is always good to have certain standards on the protocols, which will be very useful once you are doing different things at the moon, both in terms of communication, in terms of navigation, as well as doing science. So certain kinds of protocols and certain standards are certainly very, very useful.
Okay, thank you. Essa, did you have anything to add? You don't have
My colleagues had covered it all.
Great, yeah.
I feel like having international collaboration and giving everyone their expertise is a better way of doing it.
Great. So I think there's the consensus there, obviously, that there is a slight tension there because every individual organization or a country would like to also be self-reliant and self-sufficient, but at the same time, as we progress, everybody needs to also communicate with each other. So it is going to develop as the landscape evolves. So thank you very much. And by the way, for any questions, it's not mandatory that all 5 people have to respond to that. So just feel free I'm happy with that. So don't feel under obligation. Thank you. So the next question or a comment? Harry? Yeah. Please.
Harry Hiesinger, University of Münster. In fact, I have a question to Lori. So I was wondering, would you like to elaborate a little more on the use of the Argonaut lander? Because it was not really shown in your presentation. So, it's a huge asset that will allow us to do a lot of excellent science. And so maybe you could comment on that. Thank you.
Sure, I'll make just very few comments because, as I said, still coming up to speed, but I'm pretty excited both about Argonaut, and then I believe there's another element that we're working on as well, the multi-purpose habitat, which are fairly new to the architecture, and beginning that process of going through and preparing for the mission concept review and that sort of thing. So pretty exciting, the capabilities that Argonaut will provide. Being able to deliver payload to the surface, I think, is going to be critical to all of this, whether it be logistics or whether it be, other pieces of the elements that are going to be required. So pretty exciting. I know that's still kind of in the early stages and the early part of that collaboration, but I don't remember what the date is for the MCR on that one, but like I said, coming up to speed, and it seems like a pretty cool piece of the architecture. Thank you for bringing it up. Sorry, I didn't get to speak to that. As you said, there's so much going on. We can't talk about everything that's in the system. Absolutely.
So just for those who aren't aware, Argonaut is a European logistics lander, which is in development now. The first model of that should carry about 1.5 tons of payload to the lunar surface. That would provide a capability for Europe to deliver its own equipment to the lunar surface for different functions, for science, for other reasons too, but also gives us a vector to contribute to the Artemis architecture as part of our contribution to the overall Artemis architecture, just to explain what that is.
And I'm sure you will be talking more about it potentially in the town hall later.
Yeah, we'll talk more about that later on today.
Thank you. Okay, so we take a question from Barbara, just checking that there are no questions online so that we can take that next. No, not yet. Barbara, over to you.
Barbara Crowley, NASA Goddard. I wanted to follow up on that. It's awesome to see so much capability being able to go to the moon. We're still very constrained on our return capabilities. Right now, I think Orion is the only element that returns to the Earth, and it's pretty mass constrained, as we all know. So do we collectively, internationally, for this program, have plans for a return capability, especially for science, but also for other things?
James,
maybe I can go first from the European perspective.
Yeah.
So certainly from the ESA side, we have identified that return mass back from the vicinity of the moon in general is a bit of a bottleneck, certainly for science and for other things too. One of the things we'll talk a little bit about later on, but is really in the very early days of formulation, is what a European sample return capability back from cislunar would look like. So kind of a logistics back from the moon. And that's something that we're actively looking into as a potential future contribution.
Yeah. Anybody would like to add to that? No? And Barbara, so can I just check with you? So when you say return capability, do you primarily mean for the sample return, or are you thinking long-term? Evan? Good point. Thank you.
So maybe I can just say that certainly within the scientific discussions we're having within lunar exploration in general, especially on Gateway, sample return is something that comes up all the time. That's for planetary science, a lot of planetary scientists here, but also for anything related to human health research, to biology research, there's so many areas where materials, we really want to bring things back. And also in terms of there's samples for science, but there's a whole community of people that want lunar samples to do things that are not planetary science too. And so just getting more of that back is really important. And so I think that this has really come up as something which is really important to bring to the architecture.
Thank you, James. And thank you, Barbara, for the question. Any other? There's one at the back, two. So first to Roma and then next.
Hi, Roman Tartes, University of Manchester. What could be one or two of the big risks that could derail Artemis in the coming years?
Well, the number one risk for everything is always funding, budgets. And this is always a challenge. And for those from the European community that may not be quite as aware right now, in the United States, we are in a couple-year period where we're under the constraints of what's being called the Fiscal Responsibilities Act, which is limiting and capping funding in 2024 and 2025. That said, I think the 2024 appropriation for NASA is within the exploration side of the house is very good, and being able to maintain progress. But that always stands out there as one of the biggest challenges. That's just trying to keep things funded at the level they need to be funded. Technical risks always. That's part of what we do. We do things that have never been done before and that are extremely difficult. And I talked about some of the things that are challenges in getting us to Artemis 2. Talked about the thermal protection system, the emergency egress system, and things like that, our ground systems. There's challenges there. But again, we're on target, and we want to make sure that if we need to make changes and make sure that the astronauts are safe, we're going to do that. So hopefully that addresses the question.
Right. Okay. There was another hand up at that time. Lee, there is one more question there.
Hello, Paul Bremner, NASA Marshall Space Flight Center. Related to Lunar Gateway, could you elaborate a little bit more on the types of experiments that are planned for Lunar Gateway and how that fits into the architecture for the Artemis?
So I can speak to at least the NASA, the SMD experiments, because that was my background and I'm aware of what that is. That's the Hermes experiment, which is from heliophysics to monitor space weather. But I believe there's some other experiments on as well. Would you like to speak to some of the?
So I'm the research coordinator for Gateway for ESA. So I've got some visibility on what's going on in the Gateway world on this regard. So Gateway is it's a great platform to understand what it's like in deep space and what it does to stuff, right? There's really nowhere else that can do that for us. And so the first payloads, and Laurie talked about this in her slides, are really focusing on understanding what that environment is like. So the external radiation environment, space weather, but also things like plasma and fields, understanding and characterizing that well. An area which is not well characterized at the moment is the dust environment. So we'll be looking at both the impactor environment in deep space, but also the way that human activity like HLS approaching the Gateway will affect the dust environment and the environment around Gateway 2. We're also looking at inside the radiation environment, inside Gateway, to understand how the Gateway, what does a spacecraft in deep space do to the radiation environment such that you create the secondary environment that astronauts will be exposed to. And then what we're going to start to see, I think, is increasingly an emphasis on life sciences research inside Gateway to understand what that induced radiation environment in microgravity for prolonged periods of time does to biological systems, both those we depend upon, but also those that are fundamental to human physiology. We'll also do a lot of work around human health and performance research. What happens when you put humans in this environment for a long time? And so I think that's going to be an emphasis. There are some things we can really do with physical sciences, so very, very long baseline experiments, do things like quantum entanglement and relativity. But those things I think will come a little bit later. The emphasis is very much, I think, going to be on what's it like and what does it do to stuff and how is that going to affect how we explore.
Okay, still nothing online, right? Nothing. Okay. Over here, Greg has a question.
So permanent presence on the moon and eventually Mars obviously is going to require living off the land. And what I wanted to ask each of you is the priority for space resources, ISRU, and then a notional schedule for when you might see experiments and then eventual systems on the moon.
So from what I've seen so far, Greg, the initial emphasis is on trying to establish our capability, being able to land and get back safely, to conduct some science while we're there and make sure that we can bring some of the samples back and do the science research. You know, we've got several science experiments planned for Artemis 3, but those are, again, not necessarily towards the in situ resource utilization. And what I'm looking at in the architecture actually looks a little bit further out before we're at that point where we're actually prepared to actually start doing that kind of work. Do you have more to add to that, James? I mean.
So space resources, lunar resources and ISRU are things that are very important to some of our member states and for different reasons. So at the moment, I don't think we're in a position to say we're going to use lunar resources to do exploration. We're at the point where we really need to understand whether that's even possible and what the implications of it are. So one of the emphasis at the moment for us is going to be on exploring, understanding those resources. So we'll talk a little bit more about later on about Prospect, for example, which is an ESA contribution to that, our contributions to LUPEX, and some of our ideas about other things we'd like to do to understand, explore, to characterize what's there, where is it, and could it be useful, and what would it mean to use it? And on that basis, you can start to take decisions about whether or not you'd like to include that in an architecture. There's also questions about the technology, like how do you actually get something useful out of the materials that we find there? What does that take? What are the gaps in knowledge? And you'll probably hear a bit more about that during the course of the week as well. So I think at the moment, ISRU is very much a technology development. It's a scientific endeavor. And once we've got together the knowledge about what those processes look like, we buy down some of the risk, we create a better understanding of what lunar resources really are, then we're in a position to do that. But that's going to be, at least for us in our program, in terms of the scientific part of our program, that's going to become one of the focus areas for the work that we do.
I was just going to add one more piece, and that is I've just read or been reviewing one of these white papers that's being developed as part of the architecture development process. And the ones that is going to be coming out very soon is talking about what kind of infrastructure are you going to need, assuming that we can find the way to understand what the resources are and how you want to actually make use of those resources. What other kind of infrastructure are you going to need in order to support those types of activities? And so we're just at the very beginnings of trying to understand what those needs are going to be, where, what kind of distances are we going to need to be traveling, what kind of architecture or what kind of infrastructure is going to be required. So again, kind of off in the future, there's still, I think, several steps ahead until we get there.
Just wanted that to this point. The lunar resources and their potential future use is also a politically very sensitive topic, especially in Europe. And different countries in the world and even within our member states take a very different view on what that might look like. But you can't have a serious conversation about what it means to use or regulate the use of space resources or lunar resources until you really know what's there. And so I think that the first step will be to actually have a serious look into what's actually there, to characterize it and use that as a solid basis for the international discussions about what lunar resource utilization really looks like and what it means and how we do that in a responsible and sustainable way, which is what's very important to our member states.
Yeah, we're very far from thinking seriously about the space resources utilization, but again, we're really engineering oriented institute. So the way we think is that we have that, we do have that far-fetched goal in our mind, but we will take a more practical approach. How do we manage to enable a long-lasting presence on the surface of the moon? How do we make a long-term activity on the moon? So first of all, we have to survive the night. Then we're starting from the radioactive energy sources. In Japan, it's people have allergic reaction to this kind of topic. But still, if you want to survive the night, well, Slim did survive for 3 times, but that's just by luck, maybe. We don't know how we managed it. So yeah, RHU, radioactive heating source heating unit is something we're starting to think about. And we think that in this line of thinking, smaller robots really matters, because quite often, nice things are located in a part that's too dangerous for you, asking astronauts to get there. So big missions, covers bigger areas, but when it comes to a dangerous area, maybe you can ask the small robots to take the risk and explore. So yeah, we're pretty far away from thinking about the utilization, but we are thinking about the technology that's going to be useful when that is happening.
Great, thank you. Let me bring in Hessa. Hessa, would you like to respond to that question?
Yes. From our perspective, we do recognize that ISRU is really important when it comes to space exploration. Like it's not feasible to ship everything from Earth. So utilizing resources outside of Earth would be essential to maintain a human presence outside of Earth. In the UAE, what we're currently doing is exploring applied research to test technologies on what we know about the lunar resources, on how we could make utilization of it. We're on the path of doing applied research on Earth. And then upon successful completion of that, then we're thinking that using our lunar programs, we might be able to test some of the technologies that could be developed. But we're still on the initial stages at this point.
Thank you. Anil?
Of course, yes. ISRU is going to be the key. And this is essential because we can't think of carrying everything from Earth every time. And once you start thinking about a human presence and continuous human presence, you have to start thinking about the basic requirement, which is basically the air to breathe and the water to drink and the food and the place to live. So these 4 things are the one which is going to drive the ISRU in the future. And once these 4 are met only, you can start thinking about something else. Thank you.
Thank you very much. I think that was a very comprehensive coverage of question that Greg asked. I'm mindful of the time that is ticking by, but this is a community meeting, and I just want to finish by just asking a question to each of the panelists, and they have to answer just in 1 sentence or 2, which is that you have the next generation in this room, and of course beyond. If you were to actually give them a simple message, what they should look forward to in the next 10, 15 years, what would you like to say to them? So let's start this time, maybe virtual, and ask Anil first, and then Hessa, and then we come into the room. So Anil, you are first.
Let's join together and explore the moon.
Thank you. Hessa.
I would say, like when it comes to lunar exploration, it's all about taking risks. So take risks and explore.
Okay, thank you. In the room. So who has the microphone? You can start first if you like. Yeah.
Be ready for a lot of opportunities to come.
Okay.
So yeah, start doing something.
That's good. Now, the one statement I would say to all the new folks in the room is get to know your colleagues, get to know all the folks in your cohort, because it's you. You are the ones that are going to do the next generation of exploration. So get together.
That's great. Thank you. So the message is start. Yep. So I think we have to start, keep opportunities in mind, be mindful of the risks, and work as a team and network. That's, I think, is the common message that is coming from here. So with that, I would just really like to sincerely thank all the panel members. Thank you so much for your time and for sharing all those exciting opportunities that are emerging. And thank you all for being here. I know it's not easy to come this far for a meeting like that. So I think it wouldn't be a meeting if you wouldn't come here. So I think to everybody, let's give everybody a round of applause and then go for a coffee